Hello everyone and welcome back to another edition of Mr. Monroe's Math. We're going over the Eureka Math program, Module 6, talking with statistics, and now we're at Lesson 8. And we talked about this in class, the variability in a data distribution and finding the mean of a set of numbers in a series of numbers. But if we turn a couple pages to the fourth page, we go to exercises 8 through 14. So let's just talk about this for a moment and take some time to make these dot plots and compare. So consider the following two distributions of times it takes 6 students to get to school in the morning and to go home from school in the afternoon. So we have these time in minutes, and because up here we can say that just the one time and not label every single number. And we're talking about two distinct times. We're talking about the morning and we're talking about the afternoon. So to visualize the means and variability, draw a dot plot for each of the two distributions. And to be able to see and visualize the means and the variability, it helps to draw these graphs and these pictures and these images to get a better understanding of what's going on. So let's graph these as we go. Let's start with the morning. We have times of 11, so we'll put a dot above the 11, 12, we have two 14s, a 16, and a 17. So pretty steady, pretty consistent, all about in the same area. Let's look at the afternoons. We start with a 6, and thankfully they're all pretty much in order, 10, 13, two 18s, and a 19. So as you can see, the variability here is a lot different. We have a much narrower or closer cluster of values for the morning time versus the afternoon time. It's a wider range here. Okay, so let's talk about that. What is the mean time to get from home to school in the morning for these 6 students? Well, you add up all those values, and there are 1, 2, 3, 4, 5, 6 dots, 6 numbers. So you're going to divide that by 6. So we take that number divided by 6, and the mean in the morning is, we find that it's 14 minutes. Okay, so for 10, what is the mean time to get from school to home in the afternoon for these 6 students? Okay, and this is the afternoon, and the mean time for that in the afternoon, and I'll shorten it with PM for afternoon, is 14 minutes as well. If we add those up and divide by 6, it's the same value. So for which distribution does the mean give a more accurate indicator of a typical time? So which one gives a more accurate? Well, look again at the morning and the afternoon dot plots here. The morning they are closer together, more consistent versus the afternoon. Now they still have the same time of 14, equally balanced out. However, it is a more accurate depiction when the numbers are closer together and clustered. So the morning mean is more accurate, okay, and is more accurate because of the closer group of values, okay? The morning mean is more accurate given the clustered values. So take a moment, make sure you have all that down there, pause it if you have to. We turn the page and we look at this next value. The distributions can be ordered according to how much the data values vary around their means. So if we look at these different types of jelly beans, and as you know, jelly beans are my favorite. They definitely are one of my all-time favorite snacks. Okay, we could look at this and find variability and distribution for the values here. Pretty consistently right now, I have the green ones saved for later. They are definitely a great flavor to have. So looking at this, we could take this information for the 7 bags of all types of brands and see how many are in there. Okay, so the data on the number of green jelly beans in 7 bags from each of the 5 different candy manufacturers. All Good, Best, Delight, Sweet, and Yum. We could continue these with more brand names and do this on our own with, say, Starburst or Jelly Bellies or Market Basket brand or whatever it may be. We'll start with the All Good. Okay, the All Good we're dotting 40, 40, 41. So 40, 40, 41. 42, 43, and a 46. Pretty consistent dot plot here. They're very close together, very clustered together. For the best, 22, 31. Okay, so pretty consistent here. and pretty close to the values, 36, 42, 48, which is close to 50, 53, and then 62. Now that's a very widespread gap with no duplicates here. So as you can see, the more consistent average for the bags would be the all good so far out of these two. But we got 3 more groups to do. Okay, so let's make sure that we see this. 3 more groups. So if we have the Delight, 26, 36, 40. Okay, and I know this seems kind of boring right now because we're just plotting numbers, but we need to make sure we follow along with this. We got 43, 47, 50, and 52. So again, very spread out. However, it is closer together than the best brand of jelly beans. So if we turn the page, we have 2 more to go. Okay, so we look at this. Now it's the sweet version. We start with 36, 39, 3 42s, 44, and 49. So again, very close, very similar to what the first brand had for the All Good, where they were all between 40 and 46. That was sweet. Now the Yum, 33, 36, yum, yum, yum. 42, 42, 45, and then 2 48s. So again, that's even pretty close too. So it's easy to see that when they are closer together, it's easier to distinguish of what's there. Okay, so order the candy manufacturers in order from what you saw. So as you go through, you see the least difference begins with the All Good, followed by the Sweet, followed by the Yum, followed by the Delight, and then lastly, the Best. So if you look back at the Best brand, we should see that it is the most widespread and not close together. It is not the most accurate. However, if you add these up and find the mean, you may find that they are all very similar or very close to one another. So last question, for which company would the mean be considered a better indicator of a typical value based on the least variability? Okay, and your answers may be slightly different, but the mean for the All Good brand, okay, is going to be the best indicator to get the accurate mean. Because again, like Sweet and Yum, they're very close together, okay? The All Good is absolutely the closest, more distinct to get that 42 average versus the 42 average from, say, the Best brand or the Delight brand. Uh-oh. What's that on the floor over there? Huh. Whoa-oh. No names. If you lost it, then you should have put your name on it. If you lost it, then you should have put your name on it. All right. Hey, smash the like up there. That was lesson 8. We're going to do more statistics very soon. Good luck to you guys and find that variability. We'll see you later.